On behalf of 24HourAnswers.com, I welcome you to today's lesson. In this video, we're going to look at an example of Rolle's theorem, and before we go over this is the example that we're going to be covering here, so a little bit of trig involved. And what Rolle's theorem says pretty much is that if you have some function that's continuous and differentiable between two x values, look at this green curve, it's continuous and it's differentiable, especially in between these two x values that I'm calling a and b. Now also what I want you to notice is that f of a is equal to f of b. That means that these 2 points here have the same y value. If that's the case and you have a continuous function that's differentiable on this interval, then there must be at least one x value that we'll call c, roughly somewhere right around here. If we find the derivative at that point, the derivative at that point is going to be 0 because that's a horizontal tangent line. That's going to be the same thing as the slope of this secant line here. Given that we have 2 points that have the same y value, the slope of the line that connects those two endpoints on this interval, that slope's going to be 0. And also there's going to be some other value, at least one x value here, c in this case, where we're also going to have a horizontal tangent line. That's what Rolle's theorem says. It's very similar to mean value theorem, but mean value theorem, you do not have to have f of a equals to f of b. Go back and check out the mean value theorem videos that I've posted to recap on that. So if we reread this, f of a equals f of b, then there's got to be at least one c value between the a and the b, boom, such that the derivative at that c value is 0. The derivative here will be 0, just like the slope of this secant line that connects these two endpoints. So on to this example. Let's show that Rolle's theorem can be applied to f of x on the given interval between pi over 6 and 5 pi over 6, and let's find a value of x on this interval that satisfies Rolle's theorem. Well, first of all, for Rolle's theorem to work, we have to have the same y value at these 2 points. So let's start off by finding f of pi over 6. We want to see if f of this and f of this are the same. F of pi over 6, we take 2 times the sine of pi over 6. We're just plugging pi over 6 into f of x right here. And the sine of pi over 6 is going to be 1/2, and 2 times 1/2 is equal to 1. Let's repeat this for 5 pi over 6. And again, if you refer back to your unit circle, just in case you forgot some of your trig values, the sine of 5 pi over 6 is also equal to 1/2. So therefore, we do have the same y values. Now, why do they have to be the same? If we look over in Desmos at f of x equals 2 sine of x, and this is that curve, it's the sine curve with an amplitude of 2, I'm just going to restrict it down to pi over 6 to 5 pi over 6, which is going to be roughly somewhere about here to here. Notice it did cut it off. So this endpoint here and this endpoint here, if we connect those with a line, that slope is going to be 0. Well, why is that the case? If you take y2 minus y1 over x2 minus x1, you're going to get a slope of 0, because y2 minus y1, if you subtract these two y values, you get 0 up in your numerator, and it doesn't really matter what x2 minus x1 is in this case. If we subtract those, who really cares? We get 0 over something, and that's going to be 0. So what we want to do now is we've verified that Rolle's theorem will work because f of a is equal to f of b. Notice what we got here. So let's find the derivative, and let's set the derivative equal to 0. So f prime of x, the derivative of 2 sine of x, is going to be 2 cosine of x. Setting this equal to 0, which matches the slope of the line that connects these two endpoints on our graph, we have 0 equals 2 cosine of x. And if we divide by 2, we still get 0 there. And now, is there a value of x, or theta, or whatever angle or radian measure you want to refer to, where its cosine is going to be 0, but we want it to be in between pi over 6 and 5 pi over 6? You have to refer back to your unit circle here if you forget a little bit of your trig, but if x is equal to pi over 2, the cosine of pi over 2 is equal to 0. This is the x value that we want to use because pi over 2, this is our c value. It lies in between the pi over 6 and the 5 pi over 6. And that's what we called our a and our b. So let's double check this over in Desmos. Here's that same curve again, and notice right there at pi over 2, it definitely looks like if we were to draw a tangent line right here, the derivative, the slope of that line would be 0, just like the slope of the line that connects these two endpoints right here. And there you have it, a visual example of what Rolle's theorem is, and also a problem where we did a little bit of trig, recapping on some of our pre-calculus stuff, knowing the unit circle and whatnot. And again, this is very similar to the mean value theorem, but Rolle's theorem is a little bit more specific in the fact that your f of a and f of b have to be equal to each other, which leads to you having that secant line with the slope of 0. That's why we'll always set the derivative equal to 0 here when we're working out a Rolle's theorem problem. And that's it for this video. I hope it helped. Be sure to check out our YouTube channel for more videos. Links to our social media are in the description below.